This is the second video to section 1.2. Below you'll see various tables and various graphs that are helpful to display qualitative data. We have tables that show percentages. We also have a couple pie charts here, a double bar graph, and a bar graph. In this first table, we have De Anza College and Foothill College. And this table is divided by the number of full-time students and part-time students in each college. In the table at the top, notice that we take the number of full-time students and divide it by the number of total students at De Anza College in order to get the percentage of full-time students. We do the same for the percentage of part-time students. When we have this information here, it's helpful to separate this information into pie charts where each percentage is split into pie piece wedges, and the percentages should be proportional to the percent of each individual category. On the right, we use a double bar graph. In the double bar graph, notice the full-time students are the purple color, the part-time students are the light blue color. And instead of using percentages, this double bar graph uses the actual number of students in each category along the y-axis. This table below is different from the top table. This table is just De Anza College, and we have the percentage of full-time students along with the percentage of students who intend to transfer to a four-year institution. Now be careful. There might be some students that fall in both of these categories. Or if you consider the students under the age of 25, perhaps some of these students might fall in all three categories. So notice that the percentages do not add up to 100%. And the reason is we have some overlap here. Our percentages don't add up to 100%. It's very helpful to have a bar graph here if we want to display this information in a chart and show each percentage. A pie chart would not be appropriate for this data. Well, as we just said, in a pie chart, our values must add up to 100%. And here the values do not, because some students belong to more than one category of the data. On the next page, we have another bar graph. We see the ethnicity of students at De Anza College, once again broken down into percentages. To the right, we're asked, why is a pie chart not suitable for this data? Well, do all these percentages add up to 100%? No, they do not. The next question asks, how could this graph be improved? If we look at the categories below, is it possible we have students that don't fall into any of these categories? Or perhaps there are students that don't feel comfortable answering this question. We should have an other or an unknown category. Moving on to the next chart, you'll see a Pareto chart. Notice a Pareto chart is also a bar graph, but all the bars are in descending order. The bars go from the largest bar down to the smallest. So once again, this graph shows the ethnicity of students at De Anza College, broken down into percentages into several categories. If we look at the question, it says, which of the two pie charts do you think is easier to read and more informative? So let's take a look at these two pie charts. Our second pie chart goes in descending order from Asian, white, Hispanic, other. So it could be that this second pie chart might be easier to identify the slices of pie because they go from the largest wedge of the pie down to the smallest. This first one goes in alphabetical order, but that doesn't necessarily help us in this case. And that's the end to our second video for section 1.2.